Welcome back to Elas Academy, and this is circle theorem and the circle geometry. Sorry, yeah, it's the same thing. Circle theorem. If you look at the board, we draw a circle here, and a line dividing the circle to two equal parts. We call it diameter. A line dividing the circle to two equal parts is diameter. While a line from the center of the circle to any part, that is from center to this side, we call it radius. So half of diameter is radius. That is, if they give any value for radius, you multiply it by 2 to get your diameter. And when they give you diameter, you divide your diameter by 2 to get your radius. So let's look at what we call chord. Chord is a line dividing circle to two different sides. Divide the circle to what? Two different sides. So this is it. This is what we call chord. And the surroundings of circle, the surroundings of the circle, we call it circumference. We call it what? Circumference. And a line divides the circle to two different sides. We call it chord. So let us move to theorem 1. Let's move to theorem 1. So theorem 1, a straight line drawn from the center of a circle to bisect a chord, which is not a diameter, is at right angle to the chord. Now, is right angle to the chord. So now, if you look at the board, what we have is that we have a circle, and I can call this place to be A. I can call that place. Let me use another marker. So I can call this place to be what? A. I can call this place to be A. Now, to prove that XA is perpendicular to PQ, we want to prove that XA, to prove XA is perpendicular to PQ. To prove that XA is perpendicular to PQ, then let's construct. We need to do some construction here. Construction that this, we join this together. We join this together. So we want to prove that XA is perpendicular to PQ. So if you look at this this circle, so what we have here is that SP is equals to SQ. That is our radii. Our radii. SP is equals to SQ, which is our radii. So the next thing here we need to see that our PA is equals to QA, which is given to us. Our PA equals to P and QA. So from this, we need to know that AX is common to angle PAS and angle QAS. We need to know that AX, this is our XA or AX, is common to angle PAX and angle QAX. AX is common to angles PAX and angle QAX and angle QAX. So therefore angle PAX is equals to angle QAX. Look here, AX is common to angle PAX. This is one angle here, angle PAX and angle QAX. So PAX, if that should be the case, that means our PAX is equal to what? QAX. Now by so doing, we also notice that our angle PAX, that is our this angle PAX, this angle here, this place, is equal to angle QAX. Look at this. This is 90 and this also what? 90. So if angle PAX and QAX, they are equal to each other, but I want you to know that addition of angle PAX plus QAX plus angle QAX is equal to what? 180. That is, this A here plus this A here will give us what? 180. This A here plus this A here will give us what? 180. Now that is angles on a straight line. Now if that should be the case, that addition of this and this will give us 180, I can equally say that our PAX is equals to QAX, which is equals to 180 divided by 2, which gives us what? 90. Which gives us what? 90. Because let me come again. Let me come again. We want to prove that AX is perpendicular to QP, and if this is perpendicular to QP, that means it can divide this chord into two parts, which is we have 90 degree. Now AX is equal to SQ. Sorry, SP is equal to what? SQ, which is our radii. That is more than one radius. So if it is just one radius, we have, if it is one line, we have one radius. What? It is 2. That's why we have radii. Then PA is equal to what? QA. From here to here is our PA, and from here to here is our QA. So there is given. Then AX like this is common to this angle PAX. AX is common to angle this angle and this angle. So if that should be the case, angle PAS, the whole of this like this, is equal to this. At the same time, this our 90 degree here our A, angle PAX is the same, is equal to what? QAX. Now when you bring this one back and that means if you add this together, what will it give us? Because if this is equal to this, then that means they are assuming the same value. If this is equal to this, that means if this is 20, this also is 20. If this is 90, this is 90. So now don't forget we are dealing with straight line. That the PAS plus QAS will give us 180. So if the addition of this can give us 180, that means PAS is equal to this, as we said here, which is equal to 180 divided by 2, which gives us 90. So that's about theorem 1. So let's take some examples. Now if you see this question now, a chord of a circle is 16 centimeter. Calculate the radius of the circle if the chord is 6 centimeter from the center of the circle. So solution. solution. So what we need to do now, we need to draw a circle to explain this. So the whole of this is 16 centimeter. Our chord. A chord of a circle is what? 16 centimeter. This is our chord. This is the center of the circle. Calculate the radius of the circle. If the chord is 6 centimeter from the center, that is from here to here, is 6 centimeter. Okay, we have to calculate for the radius. So we have to calculate for the what? For the radius. Here is 6 centimeter. Now, the whole chord is what? 16 centimeter. If the whole chord is 16 centimeter, that means each side can be 8 centimeter. 8 centimeter. Is that clear? The whole chord is 16 centimeter. That means if I divide 16 to 2, it will give me 8. That means this side is 8 centimeter and the other side is what? 8 centimeter. So now we want to solve for our radius. Now to solve for radius now, we will use one side. So let us use this side. If you look at this side, or either this way, anyone, you can use anyone. So two sides is given to us. We have 8 centimeter, we have 6 centimeter. So from here now, let me name it P, Q, A, X. Now, to get this PX, my PX, from here to here is PX. So PX is our hypotenuse. This is our 90 degree. PX, that means PX squared equals to PA squared plus XA squared. Listen very well. We name it to be P, this is X and this is A. So we have to calculate for PX from here to here, our hypotenuse. And our hypotenuse square, don't forget, in our trigonometry ratio, cosine rule. In our cosine rule, any side facing at 90 degree is our hypotenuse. So hypotenuse squared equals to opposite square plus adjacent square. So from here now, PX squared equals to PA squared. Our PA is 8 centimeter squared plus XA, which is 6 centimeter squared. So from here, our 8 centimeter squared is 64. 8 squared is 8 and 8, 64 centimeter squared plus this 6 squared will give us 36 centimeter squared. That's our PX squared. So our PX squared, 64 plus 36, 100 centimeter squared. Then square root both sides. That means PX equals to root 100 centimeter squared. So square root of 100 will give us 10. Then this can cancel this, we have centimeter. So our radius, therefore, our radius is equals to 10 centimeters. 10 centimeters. That is our radius. So let's move to next theorem. So I give you this exercise, just try it. In a circle of a radius 70 centimeter, calculate the length of a chord which is 8 centimeter from the center. So we move to next theorem now. So this is theorem 2. The angle sustained by an arc of a circle at the center is twice the angle which it sustains at any point on the remaining part of the circumference. That means angle at the center is twice angle at the circumference. Now what we want to do now is that we want to prove that angle AOB is equal to 2AXB. Angle AOB this angle AOB is twice angle AXB. It's twice what? Angle A at this angle. This is half of this angle. So that's what we want to prove now. So let us start the proof. So we have here, we have x1, we have x2, we have y1, we have y2, and this is isosceles triangle. And in isosceles triangle, from here, like this, and this is isosceles triangle. We have two isosceles triangle. So isosceles triangle is a triangle with two equal sides. Triangle with two equal sides. So if it is triangle with two equal sides, which is isosceles triangle, that means x1 is equal to what? S2. Base angle of isosceles triangle, triangle of AOX, of what? AOX, of AOX. Our x1 is equal to what? S2. Base angle of isosceles triangle of angle AOX. Also, so no, before the second one, look at A here. A, so A is exterior angle of x1 and x2. A is exterior angle of x1 and x2. So if that should be the case, x1 also x1 plus x2 equals to A. So x plus x will give us 2x. That means A equals to 2x. Why? One exterior angle is equal to sum of interior angle. This is exterior angle and this is interior angle. So x plus x is 2x, which is equal to A. A is exterior to this x1 and x2. So addition of base angle of isosceles triangle, which is interior, addition of this and this is equal to your A. Now similarly, y1 is equal to y2. The same reason. Base angle of isosceles triangle of angle BOX. So also y1 plus y2 equals to B. y1 plus y2 equals to what? B. Why? Sum of two interior angle is equals to exterior angle. So it's the same thing. One of exterior angle is equal to sum of two interior angle. Sum of two interior angle is equal to exterior angle. That means from here we have B, y plus y will give us 2y. Now, if you look at the triangle, we have angle AOB. That means angle AOB is equal to, look at this, angle angle AOP, angle AOP, angle AOP plus angle BOP, BOP. So our angle AOP, AOP is what? A plus our angle BOP is what? B. Now from here, what's our A? Our A is 2x plus our B. Our B is 2y. Our B is 2y. So what is common here? We have 2 in the bracket of x plus y. X plus what? Plus y. Now, x plus y. Now let us go back to this circle. Our x and y, they are within which angle? This angle. Here, 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 and here. So our x plus y is angle AXB. Our XYB, x plus y is angle what? A. Therefore, AOB is equal to 2. This is our 2. What is our x plus y? Is within angle AXB. Angle AX what? AX. Angle AXB. Angle AXB. So that is the proof they asked us to give them. So thank you. We will solve more questions on this. We solve other theorem because this video now is roughly above 22 minutes. Thank you.